Okay, now we're going to do the material from test 4. So this is solving systems of equations, or working with systems of equations. Also inequalities near the end. So the big idea was to be able to solve systems of equations by either graphing, substitution, or elimination. And graphing was really just so you understood kind of the gist of what was going on behind the scenes. But the main two ways you solve a system is with substitution or elimination. So these are the most important right here. Okay, they're kind of the basis for everything else. Then we'll look at applications and we'll look at graphing inequalities and systems. All right, so let's go ahead and work a bunch of these because I know a lot of you are going to be retaking that test 4 if you haven't already. So on 38, okay, so on 38, we have to solve by graphing. So on that one, we'd wind up maybe on this one you might just rearrange it since it's easy to get y by itself. So you can use the slope and the y-intercept, or to graph it, you might just use a table of values, whatever you're more comfortable with. So if I put a 0 in for x, y would be -9. If I put a 0 in for y, x would be -3. 4, 5, 6, 7, 8, 9. So -3, 0, 0, -9. My line would be right here. Okay, that's line 1. Line 2 I'll do in red. That one, I'd find ordered pairs. So maybe put a 0 in for x. The y would be -2. Put a 1 in for x. I'd get 4 times 1 minus 2. That means that the y would be 2. And I could even do another one if I wanted. Put a 2 in for x, and I'd get 8 minus 2, which is 6. So 0, -2, 1, 2, 2, 4, 5, 6, 6. So here's that line. Okay. All right, now I really needed to do a much better graph of these two because I've got to finish this up. So that's the first part, is to graph the lines. The second part is to find this right here. And, I just did a really rough sketch, so it's going to be kind of a challenge. So what you do is you try to estimate what the coordinates would be. So it looks like, based on what I'm seeing, this appears to be, looks like -2, and then down 1, 2, 3, 4, 5, 6 maybe. So maybe -2, -6. Okay. I may have to redraw this so it's a little bit nicer. 2, 6. 1, 2. I'm just double checking. Okay. So -2, -6. All right, that's not correct. That's not where those two would be intersecting because it doesn't appear to satisfy the two equations. So I need to draw this a little bit better. Okay, so they're graphed correctly, but it's not on that little system. So let me just do a more careful coordinate plane. Let me be better about my tick marks being consistent. And this is kind of one of the reasons why graphing is not our go-to method for solving a system. Because even if you did a perfect job or as good of a job as you could, you sometimes can't see it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'd be down here at 0, -9, over here at -3, 0. Let me put another one in the middle. -2 would be at -3. Okay, -1 would be at -6. 4, 5, 6. Okay. So that's 3x plus y equals negative 9 right there. Okay, now let me do the other one again. Negative 1, 1, 2, 3, 4, 5, 6, negative 1, negative 6. So on that one, I just went and did a few more points. So 0, negative 2, 1, 2, 2, 2, 6. And then I thought I would find some that are a little further to the left since I was having a hard time identifying the intersection point. I thought it was negative 2, 6, but it turned out to be negative 1, negative 6. Okay, it was really here. So I just went down a little further with it, tried some others so I could get that line drawn better. And it was really not at negative 2, it was at negative 1, negative 6. Okay, and then that's the solution right there. All right, so graphing would be just too tedious to solve every system by graphing, so we don't. We use an algebraic means like substitution or elimination, okay? So let's go ahead, let's work a bunch of these. I'm going to work these pretty quickly so that I can do a bunch, but I don't want a really lengthy video. All right, so you can pause it or slow it or rewatch it, but let me just go through several examples of these to see if you can't follow along. Okay. All right, so what's going to happen on these problems is you're going to choose to solve by either substitution or elimination. So on this one, you might do it by elimination. If I try to eliminate my x's, I could multiply that first equation all the way through by 2. If I did, I'd get 2x plus 18y equals negative 78. The bottom equation would be negative 2x plus 8y equals negative 52. So we'd wind up with 26y, and that equals negative 130 over there on the right. So I'm just, at this point, I'm adding the two equations. So this would be, I'm using elimination, also called the addition method. So what I did was I worked on getting the things in front of the x's to be opposites, one positive, one negative, so that when I add them, see how those are going to add up and be 0 here? So I really just have 26y equals negative 130. So then I can divide by 26. It's not letting me change colors easily. It's kind of delayed. All right, and when I do, I wind up getting that y would be negative 5. All right, and then to find the x, you could go back and eliminate the other variable. But generally what you do is you just understand that the ordered pair has got to be on both lines. So take one of the two equations, and you know that the y coordinate has to be negative 5. So you're able to plug it into that formula and just work that out. So you have x minus 45 equals minus 39. So you'll add 45 to both sides to get your x. And your x turns out to be 6. And then remember that the answer is an ordered pair. So you come in and you write your answer as an ordered pair. And you put the x first and the y second. Also remember you can double check that you're right. Since I use the first equation to find the other coordinate, I'm going to use the second equation as my check. So this is my check. If it also works here, when I plug in an 8 and a negative 5, okay, then I probably did it right. Oh yeah, good. Look, I know it. I made it work on the first one, and then I can see that it works on the second one. So this is a point that's on both. We didn't graph the two, but the lines intersected. This is not how the graph would necessarily look, But what we're finding is that the point of intersection would be 6, -5. Okay? All right, so let's try another one. All right, so let's look at number 40. 40 I thought was tricky because you'll see what happens. It looks like it's going to be a special case, but it's not. You have to be real careful about your positives and negatives. All right, so on this one, I'm looking at it. I'm thinking about maybe using elimination. I'm looking at these X's. I'm seeing a 3 and a 9. I'm thinking I could turn that top problem into a 9 by multiplying by 3. Okay, so I'm going to do that. But this is +9. I need this to be negative. So let me use -3 on that. Well, then I'd wind up getting -9x minus 12y equals -15. The second equation is 9x minus 12y equals 10. It looks like it's going to be one of those special cases. Now I'm ready to try to add the two equations together. And when I do, this becomes 0, but this doesn't. See, it's negative plus a negative would be minus 24 of those. And then this is -5. And I wind up getting like a fraction, and I'm going to think I did stuff wrong, but really I have not done anything wrong. This one just is fractional. Okay, so we'll use this concept of how to handle that in just a minute. So that means y would equal positive 5/24. Now, if I did like I did on the other problem, I would take 5/24, pick one of these equations and just plug it in and for the y and work out what the x is. Okay, but if you get a fraction, if this turns out to be a fraction, remember the idea of going back to the original problem and just eliminating the other variable. Okay, so I could just eliminate the y. So the y, to make those go away, I could multiply by 3 to make that a 12 right there. Because down here I have a -12. So I'm going to multiply by 3. If I do that to the left, are you remembered to multiply the right side by that number as well? So that's 9x plus 12y is 15. Down here I have 9x minus 12y equals 10. So this is 18x. This is gone. This is 25. Here's the equal sign. So then I'll divide by 18 and I get my x. My x is 25 over 18, which does not simplify. And then my answer would be 25 over 18 and then 5 over 24. So that was kind of we kind of tweaked the method a little bit since the one coordinate was fractional. Rather than plugging in that fractional coordinate, we just went back to the original problem and we eliminated the other variable. That way you avoid fractions until the very end. You don't even have a fraction issue. See, it only happens right there rather than all the way through the whole process. Okay. All right, let's look at 41. We put a lot of these on here so you could practice. Okay. All right, so on 41, we have y is equal to 1/2 x plus 3, and then x minus 2y equals -6. Now, I'm always suspicious when they're in different forms like that they're trying to camouflage that this is one of those special cases. You know, how your lines can be parallel, or they could be intersecting, or they might be just one line on top of the other. I feel like they're trying to hide that it's either parallel or the same line. So let's see what happens. With this one, the y was already by itself, so I'm going to use substitution. I think that would work best. So the equal sign means those two are interchangeable, and then we're looking for points of intersection. So at the point of intersection, these y's would be the same. So I would get x minus 2 times the quantity 1/2 x plus 3. And then that would equal the -6. Okay. And see, right here, you've done, that's the substitution step. We're using substitution here. And I chose to use that because the y was by itself right here. So when I do that, then I have the parentheses that I have to distribute to get rid of. So -2 times 1/2 would be -1x. -2 times +3 would be -6. And then this is 1x. That's -1x. So that's canceling out. And I wind up with -6 equal to itself, which is always true. This isn't x equals -6 or y equals -6. It's just that. So this is a special case. This means the lines were really the same line. So the solution would be all points on the line. Okay, now the way we normally see it or say it, I'll take all points on the line. Can't just write -6 equals -6. I will take all points on the line, or if you say infinitely many solutions, what they did on my math lab is they said infinitely many solutions, and then they said all the ordered pairs such that, and then right there they put one of the two equations because they're really the same. Such that, so what they're saying is all points on the line. The set of all ordered pairs that satisfy that equation would be your solutions. I'll take all points on the line. I'll take infinitely many if you put that, because that's what my math lab kind of did. Okay, so that's 41. All right, now let's flip it over. There's some more. Let's go ahead and just do all of these for you. So let's look at 42. X equals -6y plus 37, -7x plus 5y equals 70. Okay, so I got to solve it, solve the system. The x is by itself. I'm going to use substitution, even though they didn't tell me that would work best, I think. So those are equal. The equal sign, oops. Let me get back to my whiteboard. The equal sign means x and -6y plus 37 are interchangeable. I'm looking for the point of intersection. So I should be able to plug that -6y plus 37 in for x. And I'd have -7 times the quantity, -6y plus 37. Write down the rest of this, plus 5y equals 70. This is the substitution step. So now I'll distribute, and I get 42y minus, shoot, I don't have my calculator, let's see. It's a 9, got to do 37 times 7. So it's 21, it's 259. And it's negative because that's a negative times a positive. Plus 5y equals 70. Okay, these are on the same side, so I'm just combining them. I get 47y. And while I'm at it, let me add that 259 to both sides to get the constant over to the right. So that would be 329. Okay. Then I have to divide by 47. I'm assuming it's going to be nice and even. Okay, and I'm trying to do this. Just do it on your calculator. I just don't have mine with me, so I'm just kind of thinking. What I'd do is look at that last number. I need it to be a 9, so I think that's going to be a 7. So that would be 49, 28, and 4 would be 329. Yep, so that's 7. All right, and then once you find one coordinate, you got to get the other one. Because you're looking for, you should be thinking on these. I'm looking for an ordered pair. So the best place to go is where, on this one, is where that equation already had x by itself. And then right there where the y is, you put your 7 that you found. So that's -42 plus 37 is -5. So your x is -5 and your y is 7. There you have it. And of course, you could check it too. If you have time, just take the equation you didn't use and see if when you plug in the -5 and the 7, does it turn out to be 70? And sure enough, that's +35. That's +35. It does work. So I know it'll work in both. Okay, that's 42. All right, so let's look at two more, 43 and 44. Okay, so 43, this is a classic elimination style. And 44 is one that might turn out to be special when I look at it. We'll see. What I noticed is that if I multiplied by 3, I'd get 18, -18. It kind of looks like it might be special. Okay. All right. So anyway, let's go back to 43. X's and Y's are on the same side. I'll probably use elimination for that. If I tried to eliminate this, I could eliminate either the X or the Y pretty easily. If I chose to eliminate the X, I would multiply the top by 4 and the bottom by 9. That would give me 36 in there, and I need one of them negative. So let's do a -9 on the bottom. So multiplied by 4 on top and a -9 all the way through on the bottom. Now I did that because I want to turn these coefficients of X into the same number part, just one positive and one negative. Okay, so this one becomes 36X minus 28Y. Move this over just a little. Okay, equals 4 times that. So that's 28, 24, 25, 268, I think. Okay, and then the bottom one becomes -36X minus 18Y equals -360. Okay, here's where we're using elimination, addition method, right? This is where the addition comes in. You add up the two and these cancel out and you wind up with -46Y equals a negative, and let's see, I gotta take 268 away from, just do it on your calculator, 360. So I wind up with a -92. So then I would divide by -46, and that would give me that Y would equal 2. Okay. Now I could go back and just eliminate the Y if I really like and got the hang of the elimination process. But typically you just take one of the two equations. You know this has to be on the line. So then you plug in that Y you just found and you work it out. So 4X plus 4 equals 40. So let me take away 4. 4X would equal 36. Divide by 4, and I wind up with X equaling 9. So then I put it together as an ordered pair, and I check it, if I have time, by plugging into the top equation, because I didn't use that to find the other coordinate. I used the bottom equation. So now I'm going to plug in a 9 and a 2, and I'm going to see if I get 67. So that's 81 minus 14. Yep, that's 67. So I know I'm right. Okay. All right. One more that looks like a classic elimination. So when I'm looking at this guy, I see the X's and the Y's are on the same side. I might jump in and try to eliminate my x's. I could bring an 18 up top and a 6 on the bottom, but I'm making all the numbers way bigger than they need to be. I can just do a 3 here. That would give me 18, but this is positive, so I need it to be negative 3 so that I get negative 18. If I do negative 3 on the left, I do it on the right. Okay, bring this over. Okay, hold on. There we go. Okay, so then I would get negative 18x plus, see the negative 3 and the negative 6y would be plus 18y. Negative 3 times negative 2 would be plus 6. And then bring the bottom equation over. When you add them, that's gone, that's gone. You get a 0 on the left equals 12. See, those aren't opposites. You get a 12. That's false. No x, no y anywhere. It's a special case. What's going on is those lines were parallel. So there is no solution. Okay, empty set would be okay to write, or null set would be okay to write. Okay, the solution is the empty set. Nothing works. That's what you're saying. Nothing works. Okay. All right, so let me stop this one. This one got a little long. Hopefully you can still watch it.